Hi, math students. This is part 2 of our lesson on solving inequalities with one variable. In these two examples, we're going to look at some special situations you might see when you're solving an inequality. For the question in part A, we're going to solve this inequality like we normally would do. So one of the first things I see is the left side we can simplify by distributing. So I'll go ahead and do that. That gives me negative 6x. And then negative 3 times negative 5 is positive 15. I copy my greater than negative 6x plus 9. My next step, I see I have variables on both sides. I want to get rid of one of my x's or cancel it. So let me cancel this one by doing the opposite. That's plus 6x, and I need to do that on both sides. So that cancels my 6x there. But over here on the left side, negative 6x plus 6x, that's also 0. That also cancels. So I'm left with 15 is greater than 9. Now, all of our previous examples, when you're solving an inequality, answers look like x is greater than 3 or x is less than or equal to negative 5. We always have x in our answer. Here, I don't though. Here I have no x. I just have 15 is greater than 9. If you think about the problems we did in our unit on systems of equations, this is going to be similar to those. I can't have an answer like I normally do because I have no x. Instead, I need to look at this result and use this result to decide my answer. If your variables cancel out and the result is a true statement, the answer is going to be infinitely many solutions. And if your variables cancel out and the result is false, the answer is no solution. Similar to what we did with systems of equations. So here, 15 is greater than 9. Is that true? Yeah, 15 is greater than 9. And so my answer here, I would say there are infinitely many solutions. What does that mean? It means I can put any number for x. I could substitute 0, 10, negative 100. I can substitute any number and the result will be true because 15 is always greater than 9. It doesn't matter which number I use. In B, it's going to be a little similar where we have a unique situation. Go ahead, pause this video and try B. B is going to start out really similarly where we want to start by simplifying, this time on the right side. So I copy 4x minus 5, and when I distribute, I get 4x minus 6. My next step, I've got variables again on both sides, so I want to cancel one variable. But when I do that, same as on the left side, I end up canceling both, and I get negative 5 is less than negative 6. Again, I have no variable. It's canceling out on both sides. And so just like before, I need to use this result here to help me decide my final answer. Negative 5 is less than negative 6. Sometimes when the numbers are negative, it helps to think about a number line. So think about when you have a number line, you have 0, negative 1, negative 2, negative 3, negative 4, oh no, negative 5, negative 6. Less numbers or smaller numbers are always this side. So here, negative 6 is less than negative 5. Or the opposite, negative 5 is greater than negative 6. So this statement here is not true. Negative 5 is actually greater than negative 6. And so looking at this result, my answer would be there is no solution. It's like the opposite of the first one. There is no number I could substitute into this inequality that would work out because negative 5 is never less than negative 6. These are two examples of two unique situations in what we do if both of our variables eliminate or cancel out when we go to solve. Go ahead, try those practice problems in this lesson, and thanks so much for watching.